So the case study now that we are trying to solve is a university data set. So what are we trying to do? We are trying to cluster these universities together. What is the advantage to say dean of the college? Say you're trying to cluster universities together. What is the advantage for the dean of the college? Probably the dean of the college would look at the related universities and look at the kind of courses which the related universities are launching. Say for example, Harvard, MIT and Stanford are related. These three are a cluster. Harvard, MIT and Stanford. The moment MIT launches Internet of Things, one-year program, probably Harvard and Stanford also want to launch that, or wants to at least gauge and see whether Internet of Things is such a big concept and will it be futuristic to include this in the curriculum? Yep, maybe. So for the dean, that is how they wish to look at. And from a student perspective, if I take the GMAT exam and if I get a GMAT score of say 720 out of 800, I need to know what are those colleges to which I wish to apply. Right? Say you want to apply to University of Michigan. Then there should be a mechanism wherein your system recommends you with universities which are similar to University of Michigan. Yeah, that is what we need to do basically, right? All right. Now, how do you find out the distance? Say you have Caltech and Cornell here. You have Caltech and you have Cornell. So how do I find out the distance between these two universities? Right? So you have how many features based on which you're trying to decide all of these things? You have SAT score as a feature, top 10 as a feature, acceptance ratio as a feature, student faculty ratio, expenses, and graduation rate. So the SAT score, higher the score, better it is. Top 10. How many students or what percentage of students were in their top 10 in their undergraduate studies? What percentage of students were there in the top 10? Acceptance ratio is 22%, meaning if 100 applicants apply, only 22 people get admitted. Student faculty ratio, for every 13 students you have a faculty professor. Expenses is in dollars and graduation rate is in percentage terms. Right, so this is the data that you have. Now if you want to find out the distance between Caltech and say Cornell, how do you do that? Pay extreme attention, friends. Here is Caltech and here is Cornell. These are the values. This is the SAT score, top 10, sorry, yeah. And what else do we have? Sorry, my bad. Yeah, top 10, you have acceptance ratio, student faculty ratio, expenses, and graduation rate. So you need to find out the distance between these two. How do you do that? Euclidean distance, square root of, say this is your x1, x2, y1, y2, z1, z2, p1, p2, q1, q2, and r1, r2. So now how do you find out the distance? It is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square plus p2 minus p1 whole square plus q2 minus q1 whole square plus r2 minus r1 whole square. Alright, this is how you calculate the Euclidean distance. And if you solve for this, this is the value that you would get. Now, yeah, this is the value that you would get, which is 41711.22. If you pay close attention, you know for a fact, or you'd come to know for a fact that your expenses is contributing to a very great extent in calculating the distance, which is wrong. All variables are equally important. How can one variable contribute significantly in calculating the distance? And if you look at the student-faculty ratio, the contribution of this towards the overall distance is negligible, minuscule, right? So we need to bear all of these things in mind when we calculate. Hence, if you have scale difference, if you have the values in different scales, here you have 6 to 13, that's one scale. 2, 3, 5, 7, 5, 5-digit number is a different scale. So if you have scaling issues, you need to transform the data. Of course, you also transform the data if you have unit issues. If everything is in different unit, you try to transform the data. How do we transform here? Using z value. Z is equal to x minus mu over sigma. And when you transform, everything will come to more or less the same scale. Absolutely. Right? When I say transform, what I exactly mean is standardizing the data or normalizing the data. Both mean the same. You either standardize or normalize the data. All right. So what do? We standardize or normalize each variable before measuring the distance, because Euclidean distance is influenced by the units of the different measurements. So here we go. We have the formula for z, which is z is equal to x minus mu by sigma. Yeah, and then you're standardizing the data here. You have Caltech and you have Cornell, and you're standardizing the data. Perfect. So there we go. When you calculate the distance between Caltech and Cornell using the standardized data, you get 3.84. Here, the values or the scale is not influencing your distance calculation basically. Also, is Euclidean distance the only way to calculate distance? Absolutely no. We have Mahalanobis distance, which uses correlation matrix. Prashanta Mahalanobis is a person who founded Indian Statistical Institute, and these were the people who were involved in devising the second 5-year plan for India. That's a very big thing. And ISI, Indian Statistical Institute, is a very big brand. All right. We also can calculate the distance using Manhattan distance. Manhattan, that's a location, right? That's a geographical location where all the houses are neatly structured. It's a well-planned city. So based on that comes this formula of distance. In Euclidean, you square the distance so as to not get a negative value and take a square root because you're squaring. Here you take a modulus of the value. All right, this is all for your numerical data. What if you have non-numerical data, which is categorical data? How do you deal with that?